Hello everyone and welcome to our O Shala by Shiksha Makers. Today in O Shala we are going to study one of the most important concept of physics, that is friction. Now to understand what is friction, we need to understand what are surfaces. If you look at different objects, you find sometimes that some objects are very smooth, but at the microscopic level they are actually not that smooth. They have lot of irregularities, and that's what creates a friction. So to better understand that how friction is created and what exactly is friction, we need to check out one of the experiment, for which the best part is that you don't need to gather any material from your side, because the experiment has been virtually created by for you by us. So let me take you directly to the experiment and show you that how the friction is created. Okay, so here we go. So if you look at this particular screen, what you see here is there are two books, okay? These two books, like this is one physics, and above physics, there is a chemistry book. And right now, there is a space between them, right? They are not in contact, as you can see here. So there is a gap. And what are these blue circles are showing to you? These blue circles are the ones of the chemistry book, and the green ones are of the physics book. And there is a gap between them, and you also need to note down this particular thing, which is on the right side, that is thermometer and the temperature over there. So if I bring these two books together, something like this, what will happen is that the irregularities, okay, you can see that blue book has a lot of this pits and holes and pits and holes. So these are irregularities. And similarly, your green book, which is this physics book, has also got a lot of irregularities. Irregularities means a lot of zigzag and pits and holes. And when I bring them together, one over each other, what happens is that these pits and holes, they get into each other and then they start to interlock. And when I try to move my chemistry book over my physics book, what I see is that on the right side, I want you people to check out that what is happening to the temperature. See, the temperature is rising, right? So what exactly happened? So what happened was there were irregularities where in the over the surface of physics book, over the surface of chemistry book, and when I rub them over each other, these irregularities, they interlocked each other, and that is what created friction. Okay, and now what is the outcome of the friction is what you can see on the right side through the thermometer. So why is this is one learning for today. Now let's go and explore what are the factors which affect friction. So for this, again, we don't need any material, but we need to go to this simulation, which you can see in front of you. Now we are going to actually learn that what are the different things due to which the friction can increase or the friction can decrease. So for this, what you need to see is my screen. On my screen, I'm just first taking on all these parameters. And then if you look at this slider, I'm now moving the slider. When I keep my slider to non-friction, you can see the surface become totally smooth. If I take it to medium, the surface become a bit irregular. When I take it to lot, which means a lot of friction, what I see is that a lot of irregularities on the ground, right? So let's see. And then in this particular experiment, we have this robot who is going to apply the force, right? So let's do one thing. Let's keep our this surface, the ground, to be very smooth for the time being, right? Let's keep it smooth. And now let's try to understand that how is the interlocking happening. If the surface is smooth, okay, then how is the interlocking happening? Is it strong interlocking? Is it weak interlocking? That we will get to know that how much robot need to apply the efforts. So if the robot need to apply more efforts, definitely interlocking is more. If the effort needed by the robot is less, then it means interlocking is also less. So let's see how it works. So robot has to apply the force. Right now, the applied force by the robot is 26 Newton. And you saw that the frictional force was also same, 26 Newton. If you increase applied force, the frictional force also keep increasing, which means that interlocking becomes, that much strong enough to counter the applied force. But if this competition or if this fight keep happening between applied force and frictional force, do you think that the box will ever move? You will say no. But the thing is, this won't happen. This fight which is happening between the applied force and the frictional force will only happen till a certain limit. So now your observation is to find out that limit. Okay, that limit was around, I guess, 48 Newton. So under 48 Newton, my frictional force dropped down and the box started moving. So remember 48 Newton for a smooth surface, right? 48 Newton applied force was needed to overcome the friction of that smooth surface. Okay. Now let's keep our surface to be a bit rough. We can even keep it more rougher. And let's see. Now this time how much is the applied force needed to overcome the friction that is given by the ground to the box, which is at rest. So again, let's put a tick on all these values so as to understand better that how much is the applied force, how much is the friction being offered. So let's see by this rough surface. So you see here, 17, no movement, 18, they fight, nothing happened. 22, nothing happened. 25, nothing happened. So we have crossed that 25 Newton thing. So if we take it more, so 63, nothing happened. And at 80 Newton, it could not move. And then 90, 100 Newton, nothing happened. 112 Newton, it is balancing friction. So we need to, okay, so at around 146 also, the friction is able to balance applied force. So is the box ever going to move? Okay, we need to check that. So we are increasing. Oh, at around 221 Newton, we saw that the box started moving. So 221 Newton was the force that was able to overcome the friction. And after that, the friction dropped down, right? So as now, what we can conclude out of this? So we can conclude that when our friction was less, that is, the surface was smooth, then the applied force that was needed was just around 25 Newton to overcome the static friction, right? And we will talk about static friction in our later classes. Static friction is something related to when the object is at rest and you are trying to move that object. So we'll talk about it in our later classes at O Pathshala. And if you increase the friction, you found that the force needed was quite high. It was about above 200 Newton. You observed it right now. And so to overcome the friction, you were required to put above 200 Newton of force. So now let me come back and let me not share my screen with you. So I'm coming back and I'm now going to conclude on what we have learned today at O Pathshala. So the first thing which we have studied today is that friction is due to the locking of the irregularities. We can even say interlocking of the irregularities of the surfaces. Surfaces are not purely smooth. We can't say that they don't have any irregularities. All the surfaces which you pick up have irregularities. And once they interlock, they create a friction, which further creates heat, which you saw through that thermometer that was kept near the physics and chemistry book when we were rubbing them. The other thing which you have learned today is the factor that affect friction. Well, there are three factors that affect friction, and today you have learned the very first factor, that is the nature of surfaces. So more the surface is rough, more is the friction because there is more interlocking of irregularities. And if the surface is smooth, then the interlocking of irregularities also becomes less. And so the applied force required to overcome that friction is also less. So in our coming classes, that is at O Pathshala, we are going to learn the other factors which affect friction. And do write to us about the topics which you find difficult to understand. And we surely will get back to you with our live and fun filled sessions on those topics, and which will make your learning a lifelong memorable one. Thank you and enjoy your day.